So we previously did the flexure calculations and then did an example where we um, did the calculations fully by hand or use some of the tables that are in the handbook. Now it actually can be even easier than that if we use some of the design aids. So we don't really use much with design aids when we do reinforced concrete. If you remember the column charts, that's an example of a design aid. In steel, if you've had steel, you use the same idea where you can use the formulas and do the calculations. You can use some of the shortcuts, or you can use the full-blown design aids to pick sections. So when you're actually designing and not just analyzing a cross-section that you've been given, which in real life is what you're going to have to do is design it, these design aids can be really helpful to get a quick answer. All right, so to use the design aids, we need to just talk about, so basically this is going to talk to us about how to use the design aids in the handbook, which are charts. What we've been doing is we know we got to these two equations for the moment in the masonry and the moment in steel, right? And we chose the minimum of those two. If I rewrite those equations in the form where I've got some number times BD squared, okay, and I just go ahead and I call that number a coefficient, and the coefficient they call that is KF. All right. Now KF is obviously different for masonry and steel controlled. So if my general equation is moment equals KF BD squared, then KF for masonry controlled sections is this part. So, and for steel, it's this part. These are the calculations we just did. The difference being is if I go into the chart with a common K value, I can see which one controls and I can get some of the key answers I need right away. So I can go into those charts with, say, a row value, or I can go into those charts with a moment value or whatever I'm looking for, and then back out the answer I need. So how do I use the KF table? So we're going to redo the last example. Our next example is going to be just using those tables directly. But once material properties are known, everything else is dependent on row. Right? So your row value is the ratio of reinforcement. So once I know what all the material values are and I go in there, I just need to know how much steel. Okay, so design aids are easily made for this, and those are in ASDE 24, ASD 34, the book that was listed for this class, which we're not really using, has an error in it, but don't worry about that. Okay, so ASD 24 is in, again, chapter 14, tables and diagrams in your handbook. Okay, so I'm going to go and just hop over to that here in a minute. Let's look at these. Okay, so if it starts with 24 here, you got to be a little careful because this is clay masonry. So the 24As are clay, 24Bs are concrete masonry. So this is the one I actually want. Flexural design coefficients for allowable stresses. So they just took all the work out of this for us, basically. So here's the one for 1750. We're going to use the one for 2000 when it gets to be our turn to take a look at this in the example. But you can see you can go down with with these different values of the demand, and you can get all the key things we need for those equations, and I could go ahead and use those and calculate those equations, or I can go ahead and go in to this chart, which gives me those KF values. So it's KF versus rho. So on the y-axis, we've got those coefficients, and on the x-axis, we have the reinforcement ratio, AS over BD, A sub S over BD. Okay, so I can go into this table, and we'll do this in our problem so that you can see a little bit better. But let's say I go in and actually, let's go back to your slides here. So I follow exactly what we wrote here. To determine reinforcing for a flexural member, you figure out the demand, right? And then you backtrack to figure out what KF value you need, because remember, we're going to set the moment demand versus the moment required, or the required versus the capacity. So if I set KF equal to the required moment over B sub D squared, okay, be sure you keep your units in inches and pounds if you're going to use the diagrams. Find the right diagram that matches with my strengths and everything else. I go in with this, I would look at it as a required KF. Okay, so this is the KF required. That's what I would call it. And I go until I intersect with one of the curves, whichever one is further right. Then I figure that go down and I can find rho. Okay, and then that's going to tell me the reinforcement ratio. And if I multiply that by BD, that's going to tell me how much steel I need. So pretty nice here. So I go in to my table. Okay, let's just pick a KF value. And let me show you here real quick. You see we've got steel, and those are linear because they're linear elastic. And then I've got my bending stress from the masonry, and they follow the shape of kind of a concrete stress strain diagram as well. So if I go in here and intersect, so let's say I just pick 100, I'm randomly picking these, and it says, find the correct diagram, enter with KF, scan to the right until you intersect FB or F sub S, whichever's further right. Okay, so let's say I go here and this is the F sub B I want. And here's the F sub S. Okay, so here's the further right one. And you'd have to look at these particular values. We'll do that in the example. Then I could go, I don't know why I keep doing that. Right, so I go down and there is my rho value. Okay, so that would give me rho, and now I can calculate how much steel I need. I'm going to go ahead and erase this because we may want to use this table again. All right, and once I have that rho value, I can calculate the steel. Or let's say I have, like the example problem we did previously, I know the reinforcing steel and I want to know what the capacity is. Find the correct diagram, determine rho, because I know in this case what the AS over BD is. So we determined rho in our last problem, so we could use that rho. Go on the diagram until I intersect FB or FS, in this case, whichever is lower. And then I figure out what my KF value is. Once I have my KF value, I've got the capacity. Okay. If you need to, you can interpolate between values if you fall between the two tables, or if you want to fall between the two values, and you can go and interpolate. But let's go next. I'm going to go back to here for a minute. So we're just going to go through the same process and use the same example problem we did previously. This will be a much shorter recording. So when you go to the next example using the KF tables, that will go through how to use these for the one we already did. So we'll stop here.